Complete tutorials on CAN protocol. CAN protocol part 4. In this tutorial we are going to see about the characteristics and signal flow of CAN bus. Here we'll start with the transmission characteristics. So the transmission of the CAN bus is up to 1 Mbps per second. The common baud rate is 1 MHz, 500 kHz and 125 kHz. All nodes are same baud rate. That's what it is called. It is also a kind of unsynchronization protocol, and the maximum length is 120 to 15,000 rate. It depends. See here we can you can just see these characteristics clearly. Say for example, as you all know in our previous slides I have said this can provide the 1000 bit kbps per second, that is 1 mbps at the length of 40 meters. So even you can use more than 40 meter of length, but the bit rate will keep on decrease whenever you are going far. Say for example, if it is 100, then your transmission rate will be around 500 kbps. Then here, sorry, 500 mbps. So here, so it's simple, it's kpb 1024 is 1 mb. So we can just consider here it is 1 mb and here is half mb or 500 kb. And 200 will keep on decrease. You can use till even 5000, but at the time the rate will be only 10 kbps. So the data accuracy will be very less in this kind of transmission. That's what it is always recommended to use it as till 40 meter length. So that's what the 40-meter length is, nothing but around 130 135 feet. So we can expect the questions like can we use the CAN protocol more than 40-meter length? Most of them answers will be no, we cannot use, because CAN will not allow like that. But the answer will be yes, you can use, but if you use the the bit rate transmission will goes lesser. So that's what then obviously the efficiency also will be lesser, so we cannot attain what we want. Then the message format. So this is what the can the data transmission of the data will be in the CAN bus in this format. So it will starts with SOF, that is start of frame. Then it will continue with the arbitration field. Here it will arbitrate, it will prioritize the message, and here it will give the control field. So in control field it will take care of the registers and the memory parts. And coming to this data field, so what exactly the data? So this is the main stuff that it requires all these arbitration, control field, id, everything. So data field, this is the exact data what you are going to send. Say for example, if you are engine ECU, the engine ECU will send the dashboard that what is the rpm at the current moment. So there the rpm will be the data. So the particular rpm will store in some registers or memory. So this will be in the control field, and it will prioritize with by using ids, that is the arbitration field. And coming to this crc, it will just check the data accuracy. The starting address and ending address will be same, or that is nothing but the crc cyclic redundancy check. Then once it happens, it will goes to the acknowledgement field, whether it is acknowledged or not, or delimiter also will comes here. So this each and every term will be see in a detail in our upcoming tutorials. And coming to this end of frame, AF. So it will start with SOF, that is start of frame, and ends with end of frame. So here this arbitration field, here it is, if it is a standard CAN, then it is 11 bits. If it is extended CAN, then it is 18 bits more, that is 29 bits. Then its a control field, it is only on 4 bits. And in data it is 0 to 8 bytes of message, that is per frame. You can accommodate 8 bytes of data. Then crc is 15 bits, and here each one has 1 bit. So this is what the data flow, this is what the data can be flow with the accommodation of these fields in the CAN bus. Each message has a id, data and overhead, and yes, it's a data is 8 bytes max, and overhead is start, end, crc, acknowledge. Okay, fine. Okay, here we have, see, Here we have the speed. So here the speed will be it's not as started. So but here what the two ECUs, how it communicates, we'll see. First, in this instrument panel, actually this one has also is taken from some other attributed, so it's not created by us, but yes, it is quite easier to understand, so we have taken. The instrument panel ECU says, can anyone tell me what block temperature is? So it is asking the block temperature by sending its ID 400. Then the block ECU sees this message, and this engine block sees and issues a message block temperature 76 degrees Celsius. By using the same ID, it will send the data 76 degrees Celsius. Instrument panel ECU sees block temperature message and display it in the console. So this this instrument panel will display it as a 76. So this is how the ECU gets it communicates. So here this will display to 76. Okay, so this is what the block temperature is. So in this way, this CAN protocol, so this is just example. You can see if the same instrument panel requests the engine RPM, then engine RPM will it will, let's say for example, it will request with some 401 ID, and the data will be requested. Then the response engine will send the RPM as some 3000 or 5000, like that it will send the response, like 300, like that it will send the response. So this is how the message transaction happens in between CAN protocol, CAN bus. Then bus arbitration. The message importance is encoded in the message ID. So lower value is of more importance. As a node transmits each bit, it verifies that it sees the same bit value on the bus that is transmitted. A 0 on the bus wins over 1 on the bus. Losing node stops transmitting, winner keep on continues. See here. See here, the control engine control is 001, then 1001, 001. So this ID is 196, and wheel speed ID is 19E. So this both will transmit at the same time. So what, how the arbitration will occur? See, 00, this is 0, this is also 0, and this is 0, this is 0, again this is 1, this is 1. As you know, CAN is a AND logic, so 1 into 1 1, 0 into 0 0, 0 into 0 0, 1 into 1 1, 0 into 0 0. So this wins and this will eliminates, hence this remaining message will keep on continue to transmit. This is 1 and this is also 1, again 0. So this 196 is a critical message, engine control message, and it's this also important message, but not so critical than this. Hence once this message completed, then this will keep on transmit with the comparison its next message ID. So obviously this will wins, because the importance of this message is coded as such. So this is how the arbitration process happens. So here we can see here in this, it will compare which one has to be in and which one has to be out. So the engine control will be in and the wheel speed will be in out, because engine control ID is 0 and wheel speed is 1. Hence it is a lower value will always gives the more importance, as well as it is a unlogic. That's the two reasons. So here bus arbitration, A, it's a 0 is a low voltage on bus by one node wins over a high voltage on the other. So this is a resistor level high, and bus level, this is a dominant level. So compared to this, obviously the dominant level will always wins this bus. Here the simple flow of CAN protocol, signal flow. Here it's wait for a end of transmission intermission field, so it will just check before there is any transmission, or before there is any checksums. After this it will start with SOF, transmit SOF, then it will transmit the next arbitration. So as we have seen in the frame format, so it will goes to the arbitration field. If the arbitration bit bus level is yes, it's satisfactory, then it will keep on transmit to next. If no, then it will be a dominant bit transmitted. If here if we coming to this, if it is yes, it's transmit the rest of the message. After that the check of CRC, then end of frame will happen. If not, then it will again go to this. Why it will go to this? The bus level and transmit levels are identical, bit time is expired, so it takes more time to transmit, hence it will retry. So here one retry, and here if it is no, it will go to dominant. If it will just compare its dominant bit is transmitted or not. If yes, then it's error status. If no, then again it will go to the next one, so that it will go. Say for example, this is a high importance message, a low importance message. Sorry, it's a critical message, the important message. So the critical message goes and transmits successfully, then this will go here, then it will compare with the important message. This is an important message, so this message will compare with the low importance message. Obviously this will comes here, then low importance message will transmit again. In this flow it will happen. So here the can has the error handling technique is deals here. Here if there is any timeout, then it will try to push it again. If this is one, and another one is error status, it will send the error status, like uh, error dominant level transmitted, recessive level monitored, it's bit error. Then loss of arbitration, recessive level transmitted, dominant level monitored, this is a loss of arbitration. So this is how the entire flow works. So for each and every signal it will keep on transmit like this. So this is the exact signal flow of the CAN protocol. Here in this tutorial we are just seeing the arbitration, so that it's again coming the same kind of concepts. So multi-master concepts, a number of nodes, not limited by the protocol, node addressing message, identifier specifies content and priority. Here node A, node N, so ABS, then EMS. CAN nodes, it's a CAN bus. This is a CAN bus. The termination will be resistor. AC connection, disconnection of nodes, broadcast and multi. So these are all just concepts of CAN. So here we can see CAN is a broadcast type of bus. This means that all, so what, so that this question may arise, what, how you can tell CAN is a broadcast type of bus. This means that all nodes can hear all transmissions. There is no way to send a message to just a specific node. All nodes will invariably pick up all traffic. The CAN hardware, however, provides a local filtering such that each may react only on the interesting. So for example, if I'm telling something, so I am one of the node and you all are one of the node, so I'm telling something, you all will able to receive the message, but only few can pick, few or some or one can pick the message if you really need it. So this can be picked and this can be filtered by the local filtering. So this is how the CAN bus will broadcast. So it is not a one-to-one communication, it is one-to-many communication. So I'm not telling only to you, I'm telling to you all. So whoever is interested to take up this message, you can take. So this is the concept behind CAN broadcasting. Then the basic configuration, here node A up to node N. So example ABS, example EMS. This is all the host controller, this is a microcontroller, this is also another controller. So this is CAN controller. So this CAN controller is invariably configured with the host controller as well as CAN transceiver. So this one will transmit and this CAN transceiver will transmit. Again it will send to this. Again to avoid EMI, we have the 120 ohm resistance as well as the shielded pair. Then it will transmit to this another node called node N, that is EMS. Then here the transceiver receives, then it will send to the CAN controller, then it will send to the respective microcontroller, then it will process the data, again it will retransmit to this, it will give a reply. So here you can consider this is me, it's you. I have some process. Say for example, I have some tutorials, I am just transmitting by the rules and regulations followed with CAN controller by my transmitter. Then by using your receiver, you are receiving this, you received. After this you are also checking it with the CAN standards. Once it is satisfied, then you are processed with your microcontroller. If you have any queries or if you have any doubts, you processed and you are again replying to me, then I can do the same process. So this is how the two nodes communicates. For this, communication should be secure, the data loss should not happen, there should be no EMI. So to configure these things, we have 120 ohm resistance as well as the shielded pair. So this is the concept behind this transmission and reception of the CAN protocol. Here the CAN bus characteristics. So this is just a truth table. but yes, of course, a bit different. Two logic states possible on the bus. There is one is recessive, another is dominant. Okay, so this is recessive and this is dominant. So always dominant win the range. That's why the name itself is a dominant bit. So dominant, if three notes are there, dominant, 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 obviously the result will be dominant, because if one is zero, other two one also zero into one, as it is a AND logic, so it will be zero. In the same way, zero, then 0 0. So when it will 1 is when all three a b c is 1, then it will be 1. So that's what, as soon as one node transmits the dominant bit, that is 0, bus is in the dominant state. Only if all nodes transmit the recessive bits, then the bus will be in recessive state. So here the bus characteristics. So wired, and before that you can look upon this. T is a transmitter, R is a receiver. Note Nodes can therefore check the line while transmitting. This is important, particularly during arbitration. So here, the bus state, it's a recessive and it's the dominant. So the high bit transmits, it's all will be recessive. If it is any one dominant bit and this will be dominant, see here it's a recessive, so it takes to be a recessive. Here the transmission speed that we have seen already, but here with one small formula have been given. The arbitration limits bus speed. The maximum speed equal to 2 into T, that is TPD. TPD is nothing but the propagation delay of the electrical medium. So because of this propagation delay, so this is another question you may get. So in what perspective the can will keep on decrease whenever the length is more? It is because the propagation delay of electrical medium. So whenever the electrical medium is the distance is more, the propagation delay also will happens. That is a natural concept of the electrical science. So here it's if it is a 40, yes, it is giving the good efficiency. If it is going more, it keep on decrease. So this is what bus lines assumed to be an electrical medium, example twisted pair. So this is the kpbs. So this is the bus transmission that you got very good understanding about the characteristics and transmission in this protocol. So we'll see continue the next protocol with next tutorial with the CAN hardware. This is also one of the important stuff that you have to aware. So yes, we'll continue with this CAN hardware in the upcoming tutorial.